Hey everyone, and welcome. Today, we are going to dive into something pretty incredible. The 3 fundamental laws that literally govern every single moving thing in our universe. We're talking everything from a simple falling apple to an entire galaxy hurtling through deep space. This is the universal rulebook for motion, and it was all written down by one person, Sir Isaac Newton.
So let's start with a bit of a riddle. What could an apple and a rocket possibly have in common? I know, it sounds kind of strange, right? One just kind of drops from a tree, the other blasts off into the stars. But here's the wild part. They both follow the exact same precise set of rules, a universal playbook that hasn't changed in hundreds of years.
All right, so let's get right into it. First up is the foundation for everything else, what's known as the law of inertia. This is all about what objects do when you when you leave them alone. And the answer is actually way simpler than you might think.
Okay, so that's the official definition. And yeah, it can sound like a bit of a mouthful, but the core idea is super simple. Things just like to keep doing whatever they're already doing. But the real magic of this law, the secret ingredient, is hidden in that last little phrase, unbalanced force. And this brings up a fantastic question. You might be thinking, hold on a second. If an apple is just sitting on a table, isn't gravity always pulling down on it? That's a force, right? So why isn't the apple moving? What's really going on? And here is the big reveal. The secret is that key word, unbalanced. You see, while gravity is absolutely pulling that apple down, the table is pushing back up with the exact same amount of force. The forces are perfectly balanced. They're in a cosmic tug-of-war, and it's a perfect tie. So they just cancel each other out. But the second you take that table away, gravity becomes an unbalanced force, and, well, you know what happens next. If you wanted to boil this entire first law down to just one powerful concept, it's this: inertia. It's just the natural tendency of any object to resist a change in what it's doing. You could almost think of it as the universe's natural laziness. Okay, so law number 1 tells us what causes a change in motion, that pesky, unbalanced force. Now, law number 2 is where it gets really powerful, because this one gives us the how. It gives us the exact formula to calculate that change. Now again, that's the fancy textbook definition, and it sounds pretty complex. But what's absolutely brilliant is that Newton took that whole relationship and distilled it down into one of the most elegant and famous equations in the history of science. I'm sure you've seen this one before. F equals m, force equals mass times acceleration. This one, simple, tiny formula is the engine behind pretty much our entire understanding of the physical world. It's how we figure out everything from the arc of a thrown baseball to the trajectory of a satellite headed for Mars. And what this equation shows us is actually really intuitive. It breaks down into 2 simple ideas. First, the more force you use, the more acceleration you get. Push something harder, it speeds up faster. Makes sense. But second, the more mass something has, the less it accelerates. And that's our old friend inertia in action. It's exactly why pushing a small rock is a piece of cake, but getting a giant boulder to move is a whole different story. All right, we've got inertia, we've got F equals ma, we're almost there. But Newton had one last, crucial piece of the puzzle. He realized that forces never, ever act alone. There is always a hidden partner involved in every single push and every single pull. And this one is just so beautifully simple and profound. For any action, there is an equal and opposite reaction. What that really means is that you literally cannot touch anything without it touching you back with the exact same amount of force. Forces always and forever come in pairs. Think about it. A rocket launch is the perfect example. The rocket isn't just magically going up. Its engine is violently shoving hot gas downward with incredible force. That's the action. And in return, the reaction, that gas pushes the rocket upward with that same incredible force. It's the same reason when you click a mouse, you can feel the button pushing back on your finger. It's always a pair. So when you put all 3 of these laws together, you don't just have 3 separate ideas. You get this incredibly complete and powerful framework. It's a 3-part rulebook that explains how and why literally everything in the universe moves the way it does. So let's just recap the whole shebang. Law 1 gives us inertia, that baseline idea that objects are lazy and resist change. Law 2 gives us the math, F equals ma, which is the recipe for how a force actually overcomes that inertia. And Law 3 reminds us that every single one of those forces is just one half of an interaction, an equal and opposite dance between 2 objects. It's just a perfect, complete system. And all of this brings us to one final, kind of mind-blowing thought.
We've seen how these laws can explain an apple on a table and a rocket blasting into space. So here's the question I want to leave you with. If these same three simple rules can predict the path of a cannonball, could they also be the very rules that are keeping the moon locked in orbit around the Earth, and the Earth in its long journey around the sun? It's something to think about.